All right. So today we are just going through a few patterns of some different antiderivatives. What's that? Alright, so first one we're going to look at is ax plus b to the n. We are antidifferentiating that as long as n is not equal to minus 1. If n equals to minus 1, that changes it up. Alright, so if you want the proof of this, if you're desperate for that, you can look at the textbook. But we don't have to be able to prove it, we just have to be able to use it. So the antiderivative, and it is related to what we did the other day. So the antiderivative of ax plus b to the n dx, we forgot that. So like we did the other day, we adjust the straight x to the n, we increase the power by 1, plus 1, we divide by the new power. Alright, and this time, because we've got more than just x, we've got that, we also divide by the coefficient of the x, and then plus c. Alright, so that's the chain rule in reverse. Remember, if I had ax plus b to the n and I was differentiating, the shortcut method comes down, take one off, times by the derivative of what's inside is the shortcut of the chain rule, and so this is the reverse of that. Alright, so if I have something like this, let's look at some examples. So 2x minus 7 to the 5. Antiderivative of, so to write that mathematically, we use our integral sign, dx. That's what tells us to antidifferentiate. Alright, so if we're looking at what the a, the b and the n are, in this one the a is 2, the b is -7 and the n is 5. So then looking at the pattern, what's in the bracket stays as it is. Our power here increases by 1. We divide by that power, and we also divide by the coefficient of the x. So it's 2x minus 7 to the 6 over 12. Quick, I want to rub this off before Alice gets it.
Mr. Simmett.
Serves you right for being late, Alice.
Never get told that.
Because for Nick it's just...
Oh, because Nick's a punt. Nick's got, you know, flexi time. Nick has some flexi time.
That's like, what do we do
He's
Wednesday?
a serial offender.
And I'd get no reaction from Nick if I said it anyway, so there's no fun for me to do it to Nick. All right, can I rub all that off?
Yeah.
Look at this, someone copying off sick.
Yeah, it's different, hey?
Oh, wow. Can you read it?
Stepping off in the world.
Yeah, it's like fascinating.
All right, so if we've got a negative power, 2x minus 1 to the minus 2. All right, same process. So, you know, the a is 2, the b is negative 1, and our power is negative 2.
You still managed to beat it. You still managed to beat Nick, Alice. It's okay. You went properly late.
I think I would just drop
How
out.
does he literally lives like less than a 5-minute walk home. He's always like,
I don't know
You
how
must
he like
leave
gets to
after
some reasons.
9.
I think it's an intentional action just to aggravate everyone in the class. That's
All right.
It's annoying.
So our power, when we're anti-differentiation, we opposite, so we need to increase our power, so that's minus 1. We divide by our new power. We also divide by the
A.
the coefficient of x. Plus c. Did I put plus c on that other one?
I don't think we did. We didn't.
If I didn't put plus c on that previous example, I would not have got all the marks on the exam.
Kind of sucks.
No, it's terrible. Good thing I'm not doing the
This
exam.
example need plus 2 as well,
Probably.
plus C.
No,
Yeah.
the
Yes.
The first example should have had plus c on it. I can't remember whether I put it
But
or not.
like the equation itself.
This here,
No, I mean like that.
yeah, I should have I not put that there either?
Oh,
That
hang
is
on.
terrible.
You did.
I've got it in my notes and I've left it out.
You did put it on.
So that's, is that one?
Oh, I did.
You put it as a general.
Yeah,
bit.
should have plus c.
Yeah, you did.
What, this one here I didn't know. That first example, the answer should have plus c on the end, and I forgot to put that.
Nick,
Was it?
if you're late, you shouldn't get the notes.
No, don't give them to me.
You should have
Aaron,
to
stop
just,
being too
you
nice
should
to
have
me.
to.
Oh, another one.
If he can't do it, then he'll learn and come earlier.
Okay, Laura. I'm fine, thank you, Jordan.
Did you get
All right. Okay, so 2 times negative 1 on the bottom is negative 2. Negative 1, negative powers mean we can stick it down the bottom. And so there would be our answer. All right. All right, we got that. I'm going to rub that off.
Not
Why do you flip
Not
it?
yet. Sorry?
Why do you flip it?
Why do I flip it? So remember index law,
It looks nice as a
into the negative 1. Index law
one on A.
means 1 over a.
Alright, cool.
So the negative power, remember negative power, the negative and the 1 over.
This is,
Yep. So because it's negative 1, there it goes down there. And you're expected to give your answers with positive indexes, so you would be expected to write it like this.
And do you lose marks for not showing the positive indexes?
Can
You
you?
would not get all the marks, no. And remember, there's no half marks in the marking, so if you forget to do something simple like that, you lose a whole mark.
If we
But-
like end up with a fractional index, do we have to like invent that?
You'd need to read the question,
Okay.
because sometimes they might just say leave in index form, otherwise, sometimes they might say in the form of
Yeah. Okay.
If they say in the form of, and then they'll have some, you know, letters in there, give your answer in that form, then yeah, you've got to write it like that. So you need to be, and these under pressure in the exam, these are the things that you miss, those little, you know, remembering to do this, remembering to go back and read the question to make sure the form that you've got your answer in is what they're looking for, stuff like that. All right.
It's a struggle in general.
All right, now I said about the -1 when n is not -1. So now we'll look at the antiderivative when n is -1.
I feel like ever since I got my braces off, whenever I yawn, it drills.
Same.
Like I never used to, but I got braces, and now when I yawn, it's just like, drill. Fine.
Yeah.
Too bad.
All right. So ax plus b to the -1 is what we're looking at. And remembering that's 1 over ax plus b. Now, remember back to our differentiation. If we differentiate log to the base e of x, what do we get? 1 on x, correct.
We're still doing the same thing.
Still doing the same thing. But this here is looking like this, isn't it? So if we differentiate log and get 1 over something, if we were to anti-differentiate 1 on x, we get the log of something. All right, we would get that. And plus c, and x has got to be greater than 0. More often written like this. So the first part's the same, the 1 on x dx. But because x has got to be greater than 0, often we see it written with these modulus signs here. And these signs here mean
Positive.
positive, yeah. So this is modulus, absolute value, from this, which means take the positive. So if it's negative, you change it. All right, so we can then extend this to this situation here. So the antiderivative of 1 over ax plus b dx or b. 1 over a, this one here,
Wait, what's that word? Oh, extended.
and then log to the base e, the absolute value of that denominator, plus c. Remember, this comes from if we differentiate that chain rule in reverse, similar to the a being on the bottom in the previous. so this is what we are using. So let's have a look at a couple of examples. Right, I'll rub this top bit off.
Yeah.
Oops. All right. So, what do we do? Is the A. And so we need 1 over that at the front. So 1 over 2. Next bit, log to base E of the denominator inside the absolute value signs, plus C on the end. And of course there's a restriction, but the restriction I didn't put in, but I should have, I left it out. Because X has got to be greater than a half for this to be positive. Now, if you have the restriction, like that I've put there, we can then go one step further. Because we're told X is greater than a half, so if you weren't given a domain, then you would write like this. Since I've been given a domain, since X is greater than half, 2x minus 1 will always be greater than 0. So since we have a domain restriction, we can take this answer here one step further, and we can say that it's a half log to the base E of 2x minus 1 plus C. And because X is greater than a half, this will be greater than 0, and everything's good. But you can only do that if there's a domain restriction. If there's not a domain restriction, you've got to leave it with these absolute value signs. Alright, something, another example, we'll point out something else.
What was that then?
Alright, so now I've got this 2 up the top. Now the thing about the number 2 is that it's 2 times 1. So when you have something that's a factor, what you can do with that factor is that you can take it and you can put it in front here as the multiplier. So you can say that's then the same as 2 times 1 over alright, so that then gets back to the form 1 over something, which is the form that we need. So what is it then? It's then 2 times. What's our A in this case?
2, 1, -3.
A is the number in front of the
X.
So it's a -3 then, isn't it? So 1 over -3 log to the base e, absolute value of 2 minus 3x plus c. So that would then be -2/3 log to the base e, magnitude of 2 minus 3x plus c. In this question we were not given any domain restriction, so we leave it as it is. All right, one more. Alright, the antiderivative of e to the kx. Now, when you differentiated e to the kx, it became ke to the kx. So the opposite to that, when we anti-differentiate, still e to the kx. But 1 over k at the front. So, a couple of examples. So this will simply be
1 over 3 3x plus c.
All right. Because methods is a little bit trickier than all of that, what if we get something like this?
Should be fun a bit.
All right. Anyone got any ideas?
Do you move anything to the front of the integral sign at all?
No, can't move anything to the front of the integral sign, no.
Would you do them separately first?
Do them separately,
Oh, that rule.
that rule. This looks quite complicated, doesn't it?
Don't do it. Put it in your calculator.
We just take out,
I really
get rid of
like-
x.
So what we want to try and do is somehow get this simpler. So how can we get that simpler?
Take the e out. Take the x out. Take something out.
Well, I'm going to suggest this. How about, if we get a minus here, how about we split it up into 2 bits, 2 terms? So 3e to the 2x over e to the x minus 5 over e to the x.
Doesn't make it
So I was
simpler.
right. I said
Doesn't make it
separate.
any simpler.
That's my question.
Well,
Can you
yes,
cancel? Can you times it? Can you
Well, what can we do here with these?
cancel?
Well, not cancel,
Factor them.
not factor them,
Simplify them.
simplify them,
Thank
very
you.
good. And when we've got the same base and we're dividing, what do we do with our indexes? We minus them, yes. So that's 3e to the 2x minus x is x. This one here, I'm just going to write, oops, not minus 1, minus x. I have to write it as minus x. Now that, then,
Can you do that green bit again?
the green bit again. The green bit, this bit here, so that's e to the 2x over e to the x, which means e to the 2x divided by e to the x, and our index laws that we did all the way back in year 9 and 10
Already 10 good times.
say that we subtract. The second index law says we subtract,
Okay.
which is e to the x. Now, I know you would have had a great maths teacher in year 10, so you would have learnt this.
Wait, did we have sentence?
Yes.
I did. I just did in that in classroom and I don't think I did any work for the entire year.
Yeah, Amy was really loud.
Oh, that's right.
Me, Henry, and JB were all complaining.
We'll have to take it.
And Blake as well, actually.
Oh,
All right,
That class is a mess.
so this first one,
did not want anything.
I know, he's huge.
what's that going to be?
Yeah.
That's gonna be,
1 over 3.
Why did 5
1
to the x over
over...
ex become
yeah,
5?
it's just
Okay.
gonna be 3.
Yeah, that's
It's just going to be 3, because
One
what's
over
k
three.
here?
It's
One.
One
One.
over 3.
Oh.
So it's just going to stay as 3e to the x, isn't it?
Yeah.
What about this one though?
Oh, because it's 1.
Negative 1.
Yeah.
Yeah, I think.
Final negative 5.
Right, so when we put all of that together, what do we get?
Positive 5, isn't it?
Positive 5, yeah. And you would then need to look and see how they want that written. Alright. Alright, so sometimes it looks quite complicated. We need to try and split it up. And it's always going to be easier if we can do something about this denominator. So split it into 2 bits. Now we've got something that's much simpler than that. Alright, anything else? Where?
Is that well, there's those 3, so like the last 3 steps. Why have you circled that middle bit?
Oh, because
I didn't.
I'm gonna,
Because like the negative.
so we've got minus 5 times 1 over negative 1. When we put all that together and simplify it, what do we get out of that? Well, we've got a negative and a negative plus 1 over 1's 1.
Can you just do that, or?
So
Yes, we did.
why can't you?
Where did the
1 over negative 1
come
equals
from?
negative 1.
Yeah, but where did it?
Negative 5 times negative
Because
1.
of
No,
that.
where did it come from?
Where did it come
Come
from?
from the rule.
So the integral of
I'm
e to the
listening.
kx dx is 1 over k e to the kx. And e to the minus x is e to the minus 1x. So the k
Oh, you bring it down in front.
We looked at that straight.
is minus 1, isn't it?
And we have 1
So it's
test.
1 over minus 1.
And then I had an Italian shindig thing
E to the minus x.
with all our Italian people.
What?
I get it.
And so then we've got negative 5 times negative 1, positive 5.
And because the 3 to the x is a 1, it just becomes 1 over 1 instead of 1. I see now.
Yep.
Oh,
I got yelled at by
Yeah,
this
no.
girl this morning.
okay.
Yeah.
Anything else before?
I got out of the car. She said... if you
All right,
can
this is,
concentrate,
11C
you can
and
do most of it,
D.
So maybe you should get to school earlier and stop talking to boys. And I was talking to my cousin.
I mean, it is a rally, to be fair.
It was just out there.